right, guys. Pardon my voice. I guess I got my first day back at school voices since I've been talking so much for 2 days, and I had to miss school today to help out my kids, not because I'm sick. It's just sounds all scratchy from talking for 6.5 hours, 2 days in a row, and I haven't talked this much in a long time. So, no big deal. Our first lesson is section 1.2 from the textbook. I have the notes here, which when I upload them, you'll have them in the video. Okay, so the first section is on points, lines, and planes. Those are the three most important, they're the defining points of geometry. Everything is made up of points, lines, and planes. So, even though they are what define geometry, they are considered to be undefined, which is kind of weird. How do you give the definition of something that is undefined? Basically, you can't put it in words. You can't describe a point without actually physically showing what it is, okay? It's hard to describe what a line is. Imagine describing a line to someone that doesn't know what a line is. It's hard to put into words. However, if you got out a paper and pencil, you could show them what a line is. That's why it's considered to be undefined. The third one is plane, and it's the same thing. No, we're not talking about an airplane. We're talking about a flat surface. Again, it's difficult to describe what it actually is because it goes on forever. All three, the line also goes on forever, and you can't really describe forever. Anyways, so those are our three undefined geometric terms. You still do need to know what they are and what they look like, but you're not going to be writing out definitions of them. They're basically described instead of defined, meaning you would describe with a picture. They're a starting point, as silly as that is, for us to build on, meaning all shapes consist of these. We would just add on to them with other shapes and other words. They are used to define other parts in geometry as well. All right, so first we've got just the basic point. A point is basically most easily drawn literally by taking the point of your, oops, that's not supposed to be so big. That would be a big fat point. Okay, so it's just by like the dot of your pencil. That is what we are going to use to describe a point, okay? But technically, if we really got, really serious about how in geometry it's considered, in geometry, a point has no size. If it has no size, how do you draw it? So it is a little philosophical there when what we use to represent a point, even though it technically does not have actual size, is just a little dot. That's what we would use to define some intersections, the corner of a shape. All geometric shapes are made up of a bunch of points. Two real life examples. Oh, I just gave you one. It's a dot. Another one would be a star in the sky. Or star in the in space. Space, there are millions and millions of stars. No one knows how many there are. There's so many of them. Each one, when we look up in the sky and we see a star, you could think of that as a point. Now, how you name a point. You name a point. Not only will it have when it's drawn in a picture, and sometimes it will have the actual physical dot, like this A, this B, and this C. Sometimes it won't have that in the picture. It's just assumed that it's there. But a point is always described by a capital letter, never a lowercase letter. All right, next we move on to lines. Lines are a series of points that extend indefinitely in two directions. So usually, again, it'll be a straight line. And what's very important to show that it goes on forever and it goes on indefinitely is the fact that you would put arrowheads on the ends of it to signify it keeps going on. If you didn't have the arrowheads, that's another vocabulary word we're going to tackle in our next class called a line segment. A line segment is just a small piece of a line. So you have to be very careful. Again, these symbols are very important when you have to draw stuff out. You have to put the arrows on it. Again, a line has no thickness or width, but in order to physically work with it and do math with it, we will draw a straight line to signify a line. Examples, you could have a dotted line, a street on a highway. Oh my God, there's rungs on a ladder. There's a whole bunch of different things that you could have. A highway or a street is really good, a good example, because a street literally, I-95, it literally, it keeps going in two directions. All right, so there are two ways, or actually technically three ways you can write or name a line. A line, now, just as I told you up here, a point is named by a capital letter. A line is labeled by either one lowercase letter, or it would be at least two capital letters on the line. So, some ways to name this line to the left. I could call it, again, also sometimes I wrote this is cursive, script. I know, misspelling cursive. I know cursive is like a dying font. We don't use it very often, even with signatures and stuff like that. But geometry is a little old school here, and they will sometimes write it in cursive, and that would just be the letter. So, for example, line R. Again, an example, instead of R, if maybe it was A, okay, and it would be written as line A. In script is just the fact that it's got that little scoop, or they could even be a little bit more obnoxious about it and be like that. So if it was something with script, that's what it would be. Let me put my R back there. Okay, so you can write it like that. Second way you can write this is using 2 points, two of the and remember points are capital letters. So the way you could write it, you could say DE, or you can say ED. But what's important is that you put a little mini line on the top. That's the symbol. Okay, that is how you write a line. If you don't put a bar on it, it means something else. The little bar with the arrowheads means something else. That B shouldn't be there. Oops, let me get rid of him. Okay, ignore him, he shouldn't be there. Okay, so those are the ways that we can write this. You can also, instead of using the symbol, if you want to write out the word line, if you were typing into a quiz on Quizizz and I asked you for ways to write this, there's no symbol. There's that symbol for the line that goes on the top. There isn't that on a keyboard. There's no way to make that. So instead of having that symbol, if you were using a keyboard to text something out, then you'd have to write out the word line, L-I-N-E, and the 2 letters. Okay, and again, for right now, it doesn't matter if you say DE or ED. That's the same exact line. Okay, our third vocabulary word is a plane. A plane is a flat surface. Again, with the no thickness or no width, but we have to have thickness and width, so we have to draw something and imagine that it goes on and extends indefinitely in all directions. So an example is a ceiling, a wall. Imagine your desktop, tabletop, a piece of notebook paper. Those can all be considered to be planes. Now, there are, again, different ways to write this. I'm going to change this to script. So let's say we have a capital K. So you can write plane, again, it's written. This one is written by either a capital script letter, okay, and you could just say plain K, or it's 3 points that are not on the same line but in the same plane. So if these 3 points were lined up, like if I had this, I could not call this line A, B, and C, okay, or plane A, B, and C, because those are on the same exact line as well as being on the plane. So they have to be more or less, they have to be scattered. So we can say plane, and the order of your letters does not matter. You want to say RST, STR, RTS, SRT. We could be here all day with all the different combinations. Understand though, K, it's capital and it's cursive, okay, or script. It is not it's not a point. So you either have to use it by itself or don't use it at all. Notice I didn't have to use, if there were more points, you just have to use 3. All right, now we got some words that we can actually define. The first one is collinear. Now, that one kind of has its definition already sitting in the middle of the word. Collinear means points that lie on the same line. So in this example over here to the right, B, C, and D, they are all on the same line. Therefore, they are considered to be collinear. Non-collinear is when they do not lie on the same line. So these 3 points, G, E, and F, they are non-collinear because you could not connect. You can connect 2 of them, but you wouldn't be able to connect 3 of them on one line. So going up here, R, S, T, they are not collinear. S and T could be collinear, meaning they could be on the same line. And, or R and T can be on the same line, but not all 3 of them the way that they are lined up there. Technically, all line, 2 points, any 2 points are considered to be collinear because you can make a line out of any 2 points. You would simply connect them. Okay, next, same concept here. This is coplanar. Okay, coplanar is points on the same plane. Okay, these do not have to be collinear to be coplanar. They are just points on a plane. Non-coplanar means one falls outside of the plane. So H, E, and F, those are all coplanar because they're on the same plane. However, if I group those 3 points with G, they are no longer all coplanar. Therefore, that makes them non-coplanar. The G is the odd man out. He is not on the same plane, so it cancels it all out, and none of them are coplanar. Next is space, just like outer space. I was talking about stars in the sky. The same thing here applies. A space is a set of points. Points can be considered like stars in the sky, so it's the same kind of space you could think of in your head. It is 3-dimensional. Again, that's kind of difficult to write on a 1-dimensional surface. Points, lines, and planes are all contained in space. Actually, all shapes are contained in space. Next, we have intersections. Intersections are where either, it depends on what you're comparing. Are you comparing up 2 lines? Are you comparing a line in a plane or 2 planes? There's different places where they intersect or they cross over and meet. So we're going to go over this. In this first example, we are going to compare a point and a line. The point here is the red dot labeled S. D is the name of the line. So S is on D, okay? S can also be considered in D. Again, those are adverbs and positional verbs where they tell you where something is located. Sometimes it'll be considered, they'll say, is S on D? Yes, it is. Maybe on another page in the book, it'll say, is S in D? Those are considered to be the same thing because D, the line, contains S. Okay? So again, there's another way to consider it. And also you can say that D passes through S. Those are all the same thing. You can also say that the intersection of D and S, they intersect at D. Okay? A point and a line will always intersect at a point. That's important because as we go on to the next examples, not all intersections are points. The next example, we have let's go purple. We have 2 lines. So a line and a line. When 2 lines intersect, they intersect at a point. As you can see, they intersect at point R. The intersection of point A and B is R. So look at all the different ways we can say this. A and B intersect at R. You can say they intersect in R. You can say they both pass through R. You can say they both contain R. And then you can also say, I'd probably say the most formal way is just to call it an intersection and say that intersection is R. All right, next one. We've got a line. Let's go green. Okay, this one we've got a line and a plane. Think of this as, again, this behind here, you don't actually see that. That's not lying on the plane. That's going through the plane. That's why it's dotted there. Think of this if I had a piece of paper and I took my pencil and I stabbed the pencil through the piece of paper. That's what you're thinking about here. Where I stabbed the piece of paper, I don't mean to be violent here and talk about stabbing, but it's you push it through the piece of paper, I guess. But where I pushed it through the paper, this would be the hole in the paper at D. That is the intersection. So when when you have a line and a plane, they intersect at a point. In this one, the intersection is at point D. So again, ways to say all this different stuff that's going on in this picture. B and D are in W. Line B, as you can see, is lying on or in the plane. Line A goes through the plane. So there's a difference between the two. So if you see this dotted area, that means it's going through it. Again, I'm drawing a three-dimensional picture here on a one-dimensional surface. So the way we're going to show off that there are three-dimensional aspects to it is by using dotted lines. You can say that plane W contains both line B and point D. A intersects W at D, which is what I was saying down here. A and B, so you understand, A and B do not intersect. It kind of looks like they do in the picture, but if you imagine the piece of paper stabbing the pencil, you have the point B, unless that pencil got stabbed right over or on, if this point of D was actually here on the picture, then you would know that A and B intersect, but it's not there. It's a different point of intersection. All right, last picture that we're going to go over here. This is where we have two planes. So a plane and a plane. Maybe two walls. You could have, the first story and the second story of a building. Each of those could be different rooms. You could have a room here, 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 and here. Those could all be different rooms. So you could think of planes as walls intersecting. Okay, now this right here is the point of intersection. Well, actually, it's not a point. It is a line. Two planes always intersect at a line. It's the only time the intersection is a line, when you have planes intersecting. Now, BC is in both of the planes, okay? Plane Y contains BC. Plane X contains line BC. So Y is like the turquoise teal one. X is the purple one, the horizontal one. They both intersect at the line. Every single point that may be on here, they're never going to draw, it's impossible. There's an infinite number of points on here, okay? I can only draw so many, but all of them are contained in both planes, and that's important to remember. So let's practice some true-false questions. This is going to be like what your homework is going to end up including is these true and false questions. Okay, so let me see. F, L, B, and C are coplanar. So let's look and find those 4 points. I've got F. L is here. I don't even know where P is. Oh, B, I'm sorry. B and C. Now, F, C, and B could technically be, they are coplanar. L is the oddball. He wouldn't be in it. However, by looking at it, when you say that they are not all on the same plane, if I actually slice through this, okay, I would have this as a plane. And then this is considered. So you got to kind of visualize what's going on. You may have to draw over your picture. So question number 1 is true. Let me get rid of this that I wrote on here so we can do the next one. Okay. Next one's A, M, and C. A, M, and C. That is true. They are all on the same line. So they are collinear. E, L, K, and B. All right, let's see about this one. Oops, I didn't want to use a highlighter. Okay. E, L, let's see, where's E? E, L, K, and B. All right. In this one is going to be false. They are not coplanar. There's no way I could hit all of those areas. I could get L and K and B on one line if I came through here and connected it like that, but there's no way to include that corner up there. So this one is false. All right, A, C, and E. A, C, and E. Those are not collinear. They are not on the same line. I had to, in order to connect these, I'd have to go, those two are collinear. These two are collinear. All three are not collinear. All right. Oops, I'm sorry. I didn't notice that it said, A, C, and E. Are they coplanar? A, C, and E. Yes, they are. They're all on top of this plane up here. Okay. So that one is, number 5 is going to be true. And the last one in this section, I keep wanting to go to that highlighter, is D, M, and B. All right, M is up here, D is here, and B is here. D, M, and B are coplanar. Now, they are not collinear. They're definitely not on the same line. But what you'd have to imagine here is, okay, if I connected, again, if I sliced through here and I sliced through here, okay, I would have them here. But it would never touch M. M is the oddball there, and he would not be on the same plane. So that is considered to be, actually, that one's wrong. That one is not true. Sorry, little typo there. D, M, and B are not. All right. I guess. All right. I know what they were trying to say there. If I wanted to, yeah, we're just going to keep it as false. That's the easiest way. I like it. Okay. All right. Moving on. And this is our last 5 questions, and we're done. Okay. Name the intersection of BC and NB. I don't even need to look at the picture. The fact that they both have B in their name, the answer is going to be B. All right, next one. Name 2 planes that intersect at line DH. Okay, so let's find line DH. Okay. Now, those lines, you can connect. You can say this bottom plane down here. I have to name any 2. So I can name the bottom one, and I would name the back one. The bottom one, again, any 3 points. You can say D, H, B. That bottom one could be D, N, B, B, N, H. It can be any of those. The letter J is also meant to be in the middle of the plane, so you could call it plane J. The other one now, the back one. This back one, I'll just pick 3 corners. I'm going to say F, E, H. F, E, H. I like to go with the corners personally, simply because then I know, that's the easiest way for me to name a plane. Some of these ones that are floating out in the middle can be a little bit confusing. There are some additional points on this one, more than are necessary in a shape. So you got to go with what you're good with, and I just happen to be like the corners. Name all the points coplanar with E, H, and B. Oops. All these colors. Okay, E, H, and B. All right, I got H already highlighted. I got E. I don't know why it's not working. right, let me try a different color. This can't be serious. Like at the very end of the video, it's not working. Let's try this, okay? All right, give it a second. Now this better. Okay, there we go. Much better. There we go. Okay. H and B is here. So it's basically the points on this plane over here on this side. And that would be C and K. Okay. Name 3 planes that intersect at D. All right, where is D? D is at a corner. So you've got this plane, and this plane. And you can write it however you want to do the letters. Off to the left, this one on the left here is FAD. FED is in the back. And BND is on the bottom. Again, you can put them in any order. You can have fun, see if you can spell a word that actually makes sense. Whatever floats your boat, just as long as you do have 3 letters, okay? You can name it by 1 letter if that letter is in script and you know that it's in fact the name of it and not just some point in the middle of it. You don't want to go less than 3. 2 is not acceptable. 2 points would indicate a line, not a plane. All right, last one of our lesson is going to be to name the intersection of a line and a plane. If you remember, a line and a plane, they intersect at a point. So BC is right here, like the front right corner of the shape. And then EFA. EFA is the top plane. So where do they intersect? The place that they have the same location is at C. So my answer is C. Okay, your homework for tonight is going to be in your textbook, okay? It will be on page 7. I'm going to list out the problems into Shobi. I will also put the page. So if you remember how to get to your textbook is going to be located on Plus Portals. I showed it to you on Wednesday, and that is where you're going to locate your textbook. So go into the textbook, go into chapter 1, and it's in the very first section. You're not going to have to flip very far to get to page 7. On page 7, I want you to do, you're basically going to be doing it all. You are going to actually, I want page 7. You are going to do numbers 1 through 20. And continuing from page 7 to 8, you are going to do numbers 1 through 10. And I like 21 through 24. You're doing all of these. Again, if you don't understand any one of those, there's quite a few true-false questions. The large majority of 1 through 20 are true-false questions. There's a couple other ones where you're naming points and lines. So you're going to do that assignment either in Shobi, in Notability. Start a nice clean piece of paper, title it page 7, 7 through 8, and you're going to go ahead and do it. Otherwise, do it on a piece of paper and take a screenshot, and you're going to submit it to the folder that says Submit Section 1 to Homework Here. That will be submitted by 7:55 Tuesday morning. Okay, not Monday, Tuesday morning. That is when it's due by. If you have any questions, you can send me an email. I'll be happy to answer it or help you. So I won't see you on Monday because we don't have class. That's a day. It's a day 2 rotation. So you have this into the folder in Shobi by before school starts on Tuesday. So make sure you can submit it. You have more than enough time to work on it during this class period because this video did not take an hour and a half. So get it done now. Make sure you know how to submit it to Shobi and it's there. Don't wait till 7:54 on Tuesday morning because you will get marked off. Okay, go have a good weekend. See you later.